Alright, we're gonna make an alkane. Okay, so go to the last reaction or the last video in the playlist. You need to be able to know how to make a hydrazone. So basically there's like two steps for this reaction for the Wolf-Kishner reduction. The first step is making the hydrazone, making literally this thing. Not gonna go over that. We already did that in the last video. I'm just gonna go over how to go from this to an alkane. So you have going to like a hydrazone, like an amine type thing, to an alkane. Okay, so first things first, it's like this reaction is driven by it's low-key driven by like low-key, I don't even know why I'm talking so much. It's really, you could just read this right here. It's like the most thing to remember is that this reaction is gonna like, it's thermodynamically favored. You're gonna form like nitrogen gas, and in the last step we're gonna form the last step is driven by pKa because there's like a big difference. Whatever, let's just get straight into it. Okay, so we have our hydrazone right here. So okay, remember we're in basic conditions, so do not form a positive charge. I wrote it right here. We're in basic conditions, do not form a positive charge. So let's start. Okay, so all these notes on the side, just like be comfortable with understanding what it means, especially the things that are highlighted. Okay, so we have to do acid base. Okay, so we have NaOH, and let me just be a little bit more neat. So we have OH. Okay, so the first question, we have to do acid base. So the first question is right here, how to find the most acidic proton. What atoms are attached to hydrogen? So we have carbon. No, we look, you have nitrogen only. What atoms are attached to hydrogen? Yeah, so nitrogen, right? And carbon. Nitrogen wants to charge, so he's gonna be attacked. So this is the, I don't even know why I missed out. Yeah, that's it. Okay. This is gonna go straight onto nitrogen. Okay, this 5 steps. These are all the 5 steps. I laid it out. Okay, so we're gonna do acid base, acid base, acid base, elimination, and then acid base again. So okay, acid base. Um, Once you form a charge, you should already be able to be. You should be comfortable making a resonance structure. Okay, so it's gonna look like. Why did I write it like this? Yeah, I'm bugging. Yeah, that's it. Okay, right here. And then he has a negative charge. Um, yeah. So now just move the pi things, and this is gonna move here, and this is gonna move here. So now we're gonna form right here. We're gonna have a plus charge on that. Now we're gonna have a negative. See, first off, we're in basic conditions, so me even writing a plus charge is wrong off the jump. Okay, so it's a negative right here. Yeah, put this in 2x. I know I'm going mad slow. Okay, and then yeah, H like that, low key, or we could just make it like cleaner. Okay, but so now again acid base. So what is gonna be doing? What is this? See, you have a lone pair, literally a negative lone pair. He's gonna be attacking. So we formed water right here. So that's gonna attack the water. So just draw water, and boom, it's gonna attack the water. So that's our second step. Okay, acid base. Now again, another acid base. So now just whatever it formed. So that thing is like taken care of, right? No more charge. And okay, so now we formed this, right? Like this is gonna become hydroxide, right? So now hydroxide is gonna do acid base again. So who is he gonna attack? In the last example, he attacked here, right? What is the most acidic proton? Wait, which atom? Yeah, we're finding the most acidic proton, right? This is the most acidic proton because it's attached to nitrogen. So again, do another acid base. Okay, put that on nitrogen. So now we got nitrogen, and he's negative, right? So charge, right? Every time you get a charge, do some resonance, a delocalized charge. So just push electrons, right? So wait, acid base, acid base, acid base, elimination, then acid base. So there's no resonance. I'm sorry, I don't even know what I meant by delocalized. Loki, half the time I don't even know what that means. I'll be honest. Okay, so this is the elimination. Okay, we're gonna be forming nitrogen. So this is gonna go straight onto here, and this is gonna go straight onto the carbon. Okay, what's gonna happen is we're gonna form N2. N2, and make sure you write bubbles out. Okay, you bubbles out, and then you're gonna form a negative charge right there. Okay, last step. Okay, last step is acid base. Okay, what did we form right here? We formed the water. So what do you think is going to be attacking? It's going to attack the water. Okay, so just make sure you understand this. The pKa of water is 14. Okay, that's kind of easy to remember. It's 14. You know, I don't even know how to explain it. Just 14. So it's like pKa is equal to 14. pKa of alkene. What is it equal to? So okay. First off, pKa, we have this right. We have that. This is not even alkane yet. It's not alkane. This is gonna form into an alkane. So this is gonna attack here. It's gonna attack that hydrogen, and then boom right here. So now, one arrow. I'm gonna put it under here. So now we formed our alkane. Bam. So we formed an alkane. Alkane pKa is equal to 50. Alkane, the pKa of water is 14. So 50 minus 14 is gonna go to the right. Alkane is a lot less acidic. The lower your pKa is, you're more acidic. So KEQ is equal to 10 to the 36. It's irreversible. So just write irreversible. Okay, bet. That's really how you find it. That's how you do the answer. And then make sure you regenerate the answer, right? You regenerate the OH. So just write OH right here. Just make it a little clean though, you know. Okay. Yeah, that's it. So I'm just gonna go over my little notes that I wrote on the side. Is this reaction is weird because we have carbon with a like a negative charge. Something needs to be thermodynamically favored for that to happen. Okay. There's like I know in other exams we learned about H2 palladium over carbon to make a ketone into an alkane. This one's different. We need to have something super strong. We need something super strong for this to happen. That only H2 palladium over carbon only works if like your molecule or whatever is benzoic. We don't have benzoic. Okay, that's why we're not using it. Yeah, this is just a note. Just make sure like this reaction is easy because it's Wolf-Kishner. You could locally remember Wolf as in like acid base, acid base, acid base, acid base. No, no, no. It was acid base, acid base, acid base, elimination, acid base. But honestly, that's low-key stupid. Like trying to remember all that. I think if you just remember the flow of arrows, it's a lot easier. Or you can remember the fourth step is elimination. Everything else is acid base. Okay, that's really it. So just literally, just remember the reaction. I'm yapping now. I'm done.